because I bought it just a few days ago. Because the old version of Snagit was blowing up on my MacBook. And so I bought a new updated version to see if that fixed MacBook. It fixed MacBook. I could do my iOS app development class today, but and record it. Okay, the shell method. Shell method. Let me show it to you. It's a very similar concept. Where's the book? Okay, so we have a region again here, and you see how we're revolving it around this right here. And it's kind of weird. You'll see from the formula kind of how it kind of goes against what we were looking at with the other method. Like this. Shell method about the y-axis, and your graph's bordering the x-axis. Before, we were concerned if it was revolving around the x-axis, that'd be bordering the x-axis, right? So this is different. We're going to revolve it around the y-axis, but specifically the graph has to be down, bordering the x-axis. You see the difference on those? I'm not going to really have you explore it, but if you were to work the problems where you decide which method was best, you're looking for the one with the cleanest setup. You know, if it's bordering something, then you can do that. You know, if I had a problem where it was here, like this, then you try to avoid the washer situation, right? So you try to go with something that's bordering. So there's a lot of different tips and tricks you'd look for, and which method would be best to set it up. Okay, I'll flip back to this. Well, let you finish writing that down. Okay, about the y-axis. Oops. This one's about the y-axis, so let's look at this one. On the test, I'll ask you to use the disk method or the shell method. You won't have to sit there and figure out which one. And I'll just do the setup on these. Okay, about the y-axis, graph is bordering the x-axis. Is it bordering the x-axis? Yeah, exactly, isn't it? Now, if it wasn't bordering the x-axis, you'd use this note down here, which we'll talk about in another problem. But we don't have to worry about this note. We're just going to do this. So volume, this is number one, is 2 pi from A to B. A and B are in terms of x values. 0, 3. And then we're going to have an x. This is truly x. So it's not a function or anything. It's just x. times, and then this is h of x, which is our function, which has to be of the form y equals. And this is of the form y equals, so this would be 2x and dx. I could probably do this one. 2x squared, so 2/3 x to the third, 0 to 3. That's 27 divided by 3 is 9, times 2 is 18, 36 pi. Yeah. Questions on that one?
So in this one, you're rotating about y, but everything is expressed in x, right?
Right, because it's bordering the x-axis. So yeah, it's weird because you're going around the y, but then everything has to be in relation to the x. Now, if I was going to revolve this around the y-axis using the methods from the previous section, what would I have? I'd have so I'd have that gap, wouldn't I? So I'd have to do the washer, which isn't horrible. But again, the idea is, try to go with the simpler one. And you don't get much simpler than that integration. Okay, number 2. So y equals x to the fourth. Y is equal to 0. X is equal to 2. Pretend that's the correct graph. Y equals 0, be that right there. X equals 2 would be this right here. Okay, so that's our setup. That's our picture. It tells us to revolve it about the y-axis. So it's still this one because it's about the y-axis and the graph is bordering the x-axis, isn't it? See how this is bordering the x-axis? So our setup, volume, is equal to 2 pi. A to B, A and B are in terms of x values. So it'd be what? 0 to 2. Yeah, that's right. Yeah, because the A and B are in terms of x values, and I didn't write it, but that's 0 to 2. And then I have to have an x here times, and our function, and it has to be solved for y, which this one is solved for y. And is there no squared? No squared. So dx. I might even be able to do that one. That's x to the fifth. That'd be 1/6 x to the 6. 0 to 2. 2 to the 6 is 64. Divided by 6 is 32/3. Times 2, 64/3 pi. Yeah. Okay. Had a professor at Wichita State, Professor Richardson. I think I mentioned him last time. He would never use a calculator. If he was going to multiply 312 times 57, he'd do it over on the side. And you see him doing this, and you're thinking, oh my God, have you ever heard of this invention called a calculator? And he goes through that almost entire semester, and he says, you probably wondered why I'm doing every one of these by hand. And he says that Alzheimer's runs in his family real bad. And he did a lot of research, and research shows that if you do basic math, it will stem off Alzheimer's. And this guy is sharp. I think he's retired now, but so I don't doubt his word on that. He couldn't find anybody sharper than him. Well, yeah, there is. Is Dr. Isakov still at Wichita State? The Russian? Sure, he was a sharp guy. He'd bring like grants and millions of dollars to WSU. I started taking one class with him. I dropped it after 3 or 4 classes. I couldn't understand a word he was saying. Now, my accent is probably not great. Russian accent, real thick. Guy's a genius, don't get me wrong. Except for I couldn't understand one word he was saying. He kept saying the F word. And I'm saying, why does he keep saying the F word? I finally asked another student, said, why does he keep saying the F word? And so, well, he's trying to say factor. And it's came out wrong. He'd actually get in trouble if he talked too much, because they wanted him to do research, as sharp as that guy is. Y is equal to x squared. Y is equal to negative 2x plus 3. X equals 0. And about the y-axis. Are these all y-axis? Save time, I won't graph this one by hand. I'll just use Desmos, even though this would be easy to graph. I think my favorite professor at Wichita State was Dr. Chopra. Have you ever have him if you're from WSU? No. Sweet guy. Good teacher. In graduate classes, you have to get a B or you get on probation. C doesn't count. 2 C's means you get kicked out of the program. And so into the semester, I'd always be borderline between a B and C, and he'd call me in every time and say, David, I need to talk to you after class. And it's like, I got some extra problems you need to do. It's like, oh, okay. I appreciated it. Sweet guy. Okay. I guess x equals 0 is... Oh, the red. Okay, right there. So, looks like this area right here, doesn't it? So that's what we're working with. And it looks like it's bordering the y-axis, right? So, and let me see. About the y-axis. Unfortunately, okay. Now this one is bordering about the y-axis, but the easy form is it's about the y-axis. There. This one. Okay, so it's about the y-axis. Graph is bordering the x-axis. Assuming I wrote it down right. Did I write it down right? Did it say y-axis? Let's look. Okay, that's the first slide there. Yep, about the y-axis. Okay, so this one. So we're on this one, but it's not bordering the x-axis, so it's not our easy form. So I come down here. If your graph is not bordering the x-axis, then we're going to do this note right here for our h of x. So let's do the setup on that then. Volume is equal to 2 pi From A to B. A and B are in terms of x values. Yeah. So 0 to 1. And x is just x. That doesn't change. Times my h of x. H of x has to be solved for y. So let's see if these are solved for y. They are solved for y, so that's perfect. And down here then, it says h of x is the graph furthest away from the x-axis. The graph furthest, here's the x-axis, graph furthest away is this one right here, the straight line, isn't it? So that would be the negative 2x plus 3. Minus the graph closest to the x-axis. Yeah. Dx. And then that would give you your answer. Very good on that? Okay. So it has to match exactly that title. Otherwise, you have to go down to that very bottom note if it doesn't border it like it says it should. How many of you have taken math classes at WSU? Just one. So I'm asking about 2, 3. Dr. Sun, have you taken him? Isn't he great? Oh, haven't. Oh, okay. Yeah, Dr. Sun was great. I took as many classes I could of his. It's funny. One time he was working a problem, and the problem involved like 20 steps. I mean, a whole bunch of steps. And he went from the problem directly to the answer. And somebody in the class raised their hand, said, "Could you show those steps you got to get to the answer?" And he looked at them like they were asking him to explain why 2 plus 2 is 4. He was doing his hand like this, and then he just went on. So yeah, he's great.
Use your brain.
I wasn't the only one. I needed to see those like 20 steps he skipped too, but
I mean, just imagine it.
I can't imagine somebody as sharp as him to be able to do all those steps in his head. It's just unreal. Let's see. That was number. Erased it. Number 3. Okay, number 4. Y equals square root of x minus 1. Y equals 0. X equals 3. Okay, I'm going to use Desmos to quickly come up with the graph. Y equals square root of x minus 1. Y equals 0. X equals 3. Okay, so that's what we're working with right there. This right here in the middle. It's going to be revolved about the y-axis. I wonder why I got so many y-axis in here. It's like our third y-axis, isn't it? Or about the y-axis. Is our graph bordering the x-axis? Yeah. So this one's a simple form. So I'm going to do volume equals 2 pi from A to B. So what would I go from? The what? 1 to 3. And then x times h of x And h of x is has to be the form y equals, which this is already in the form. Oh, okay. Let's do this one. This is an interesting one. By hand, that is. At least till we get to the part where we plug in the numbers, then I may stop. How am I going to solve this? The reason why I'm going to focus on u substitution a lot is because Larry Friesen on the left, he said differential equations. He says use tons of u substitution. So.
First, the square root to the power?
Eventually you need to do that anyway, yeah, because we can't do anything with square roots, right? What would u be?
X minus 1.
X minus 1. Now that'll count for this, and then du will be dx, because the derivative of x is 1. How do I get rid of this x here? No, can't bring variables in and out of an integration. What?
Divide by x.
No, can't divide both sides by x. We're going to take this one. This just blows my mind on this one. You solve for this variable, so you solve for x. U plus 1. Seems weird. I mean, we let this to equal u, and then we use it to, again, so it's just, okay. Keep in mind these are x equals 1 and x equals 3. We're going to replace the x here with u plus 1. And this is u to the 1/2 du. So then multiply that through. U to the first times u to the half gives you u to the 3/2. 1 times u to the 1/2, u to the 1/2, du. Add 1 to your power, divide by your new power. So that gives me 2/5 u to the 5/2 plus 2/3 u to the 3/2 from x equals 1 to x equals 3. Plug my u back in, whatever I said u was, x minus 1. Five halves plus 2/3 x minus 1 to the 3/2 from 1 to 3. There's a danger when you still got his u that you plug these in for u when they're different variables. You can't do that. You have to do that. Plug this back in first. And this could be what he was asking about with the u substitution. Because some people are taught to change this to u equals your limits of integration and then plug that in. How were you taught in Calc 1?
I think she showed us this one.
They showed you both? Yeah.
No,
But
I think we mainly focus on the x equals.
Oh, did you?
I think so.
I think it's easier to understand. That's why I do it this way. But I show both in Calc 1. Now the 1's going to drop away because 1 minus 1 is 0. So I just need to worry about 3. So this is going to give me 2/5 times 2. Yeah, 3 minus 1 is 2. 5/2 plus 2/3 to the 2 to the 3/2. And that's good enough for simplifying. Questions on that? You don't got it down? That's fine. I'll flip back to it here in a second. There's 4 more problems left. There's no way I'm going to do four problems in 4 minutes time. So we're not done with 7.3 yet. We'll work on that some more next class, and then go on to 7.4.
So would you be okay with the answer like that? Like that?
Oh yeah.
You would?
If you're wondering what you could do, is you could factor out See how they both have 2 to the 3 has power?
Yeah.
You could factor that out. Like that. You could probably do more with that 2/5. And when I take that away, that gives me 2 to the 2 over 2. Because 5 has minus 3 has gives you 2 over 2.
Yeah.
And this one will just give you 2. And so then this is 2 pi. This one gives you 2 square root of 2. That's 2. That's 4/5 plus 4/3. And then you go down. So that's really the simplifying way. No, you wouldn't have to go that far. We're done. Have a good rest of the week and weekend. And I apologize for that losing the video on that first section. If you do, if you're counting on that video to watch later on, as you're working, and if you need to see any of these work, just email me. Say, hey, work this problem, and I'll work it and send it back to you.